So when you're solving equations, not all of them are just one move and the variable's by itself. Some of them require more than one step to get the variable by itself. In order to figure out which thing to do first, you have to think of your order of operations. Your PEMDAS. And then you've got to go backwards. So what I'm going to do is I'm going to write my PEMDAS up here so that I can remember my order of operations. But when we're solving, we're going to go this way. SADMEB. SADMEB. Okay, not PEMDAS, SADMEB. To undo and to solve equations. Which means we're going to look for addition, subtractions first, and then multiplications, divisions, and then exponents, and then parentheses. All right, looking at example number 5, what kinds of things do I see happening?
5x minus 6.
I see 5x, so I see a multiply happening right here, and then I see a subtraction happening right there. According to PEMDAS, I should do the multiplication first, but when I'm solving, I have to go backwards, so I need to do the multiplication last. I'm going to handle that addition, the subtraction first. How do you undo subtraction?
You multiply. I mean, you add.
You add. So I'm going to add 6 to both sides. Now notice I'm keeping them very vertical column.
It's negative 30.
Okay, negative 30 on this side, you said. And then over here, I'm left with just the 5x. Now I'm going to ignore everything above this line. I'm going to look just right here. What's happening to the variable here? What's happening between the 5 and the multiply?
Multiply.
Yeah, it's multiplying between the 5 and the x, which means I have to divide. And the result is negative 6.
He's all yelling.
Okay. Let's look at number 6. Here's the variable. I've got a multiply right here. Okay, so there's a multiply of negative 2 happening here. Multiply negative 2. And here, there's a plus 8 happening. An add of 8. I need to undo addition, subtraction before I undo multiplication, division. So I need to get rid of the 8. It's adding. How do I get rid of addition?
Subtract.
Subtract. So I'm going to subtract the 8 from both sides. That's going to make these two cancel because I'm using inverse. On the left we have a 6, and on the right I'm left with negative 2y.
What's the final answer is?
Not yet. We need the y by itself. Remember, we're trying to solve, so we want the variable all alone, isolated. We stated earlier that this is a multiplication kind of thing. How do you undo multiplication?
Divide.
What am I dividing by?
Negative 2.
Beautiful. 6 divided by negative 2 is negative 3. Is the variable alone? Then I'm done. Example 7. I have parentheses. The parentheses according to order of operations have to be done first, but remember we're doing opposite order of operations because we're solving. So I need to do the parentheses last. I see a multiplication happening out here with the 3. So I'm going to get rid of this multiplication of 3 first. How do you undo multiplication?
Division.
Division. So I'm going to divide both sides by 3.
It's 24.
And then I'm going to divide everything by 4 because 4w means 4 times w. 6, you said?
No, it's 24.
24 divided by 4?
Yeah. It's 6, right?
Oh yeah, 6.
Okay. Now during break and before this video, I had a question. Someone was trying the extension questions, which was fabulous. And they asked, what do I do here? How do I get rid of this fraction? Well, let's figure out what's happening to the variable first. The fraction is being multiplied.
Don't you just flip the fraction?
Oh, I love that question. Don't you just flip the fraction? You can, but sometimes that doesn't always clear it completely, especially if you've got other things happening, okay? And so what we want to do is we want to get rid of the fraction. That should always be your first move when you see fractions. Remember that fraction is division, so I'm going to select to get rid of the division first. How do you undo division? Multiply. What are we dividing by over here? What's in the bottom? 5. 5 is what we're dividing by because the 5 is in the denominator, and so the 5 is what we're going to multiply by. These are inverse operations, so those disappear, and I'm left with 4x on the left and 12 times 5 on the right. Now I see 4 times x. To get rid of multiplication, you use, and we're going to divide by 4, and that's 15?
Yes.
Okay. The variable's isolated all by itself, so I'm done. Okay. I've got another crazy fraction in example 9. All right. I have addition and I have division. Now, order of operations says we have to get rid of that addition first, but notice how that addition is happening inside the top of what we're dividing, which means we're going to have to get rid of the division before we can get at that addition. Okay? So I need to undo division. How do I undo division? Multiply. What do I multiply by? 3 in this case, because that's my denominator. These 3 cancel. I'm left with n plus 8 equals negative 30. From here, what's next? Subtraction. What am I subtracting?
8.
The 8, which means I'm subtracting the negative 30 and the negative 8. Negative 30 minus
Negative
8
38.
is negative 38.
Whoa.
My variable's by itself.
Got it.
All right. Do you want to see example 8?
No.
I heard a yes? Okay.
Yes.
Because look at the difference between 8 and 9. Notice how with 9, the addition, subtraction, was in the top of the fraction. It was part of what was being divided, so I had to clear the division first. This one, that subtraction is outside of the fraction. It's not part of the division, and so I'm allowed to clear the subtraction before clearing the division. Then from here, to get rid of that divide by 2, I should multiply by?
2.
Good.
So you always get the what, the denominator?
Yes, sir. Always grab the denominator. It'll clear the fraction, even if I've got a not 1 in the denominator, or the numerator. I've got something else up
So
there.
you got like a 6, it's gonna clear it off?
Yes. 104, I think?
Yes.
Okay, good. Thank you. All right. I want to leave you with one last example before you get some time to work on that daily work. We're going to translate, and then we're going to solve. All right. Find your equal sign phrase, because we were told this is an equation, so there should be an equal sign phrase. Is identical to. So there's my equals. All right. Let's look at the front part, the left part. What does the word quotient mean?
Divide.
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 All right, what 2 things am I dividing?
X and 12.
And 12. Good. What did ratio mean? You can look in your English to math dictionaries, the math cheat sheet, which should be in the front of your
Use
notes.
this one. Eric, use this one. Oh my god, your wallpaper.
Okay.
He was trying to go to Google,
Yeah.
and his wallpaper got spotted. We don't judge, dude. Go to your math
Yeah,
English
I like
dictionaries.
that.
It should be in the front of your notes. It's a division thing. What 2 things am I dividing? All right, so there's my equation. Now I've got 1 fraction equals 1 fraction. Have you seen this setup before? Yes? Okay, those of you who have, because I had a few shake their heads, and that's okay. If you've seen this setup before, what have you wanted to do with this setup? Cross multiply. Yes. And so whenever you see fraction equal sign fraction, you are allowed to cross multiply. That means I'm going to take the top of one side and multiply it to the bottom of the other side. And I'm going to do the same over here. Bottom of one side times top of the other. I think I multiplied that right. 11 times 12, I think, is 132.
Nobody's eating it.
Oh, 132. Oh, I had a flip my numbers moment. 132. Ooh, goodness. Okay. I want to get rid of the 14. What do I use? Divide by 14. I'm definitely going to need help because I have no idea what 132 divided by 14 is. I love the reaching for the calculators. That made me happy. He's saying 16.
No.
Maybe?
No,
It's not 16. It's probably like 9 or something. It's a
Yeah.
decimal? Okay.
It's
Throw it out there.
9.4.
Yeah.
Okay. We'll talk later how to simplify the fractions so that you can get your answers as fractions. Decimals right now are going to be all right with me. All right. Thank you very much.